In this video, we're going to continue our discussion with probability. Before we do that, let's talk about what's called an unusual event. This is an event that has a probability that is less than 5%. So we will talk about unusual events in this course. Remember, if the probability of an event is less than 5%, then it is unusual. An impossible event is an event that has a probability of 0. Well, the example of rolling a 10 on an 8-sided die is an example of an impossible event. A certain event is an event that has a probability of 1. So on an 8-sided die, the probability of rolling a value greater than or equal to 1 is 8 over 8, which is 1. That's a certain event. All right, let's talk about a probability model. This lists the possible outcomes of a probability experiment and each probability's outcome. So we want to determine if the following is a probability model or not. Okay, so we're looking at the color of Skittles. Each probability, is it between 0 and 1? The answer to that is yes. So the next thing we need to do is to add up the probabilities. Well, adding those up, that is 1. So this is a probability model, and I'll write this out now. This is a probability model since each probability is in between 0 and 1, inclusive. And when I take the sum of all the probabilities, they do add up to equal 1. All right, so suppose we roll 2 4-sided dice and take its sum. I'm going to draw a picture to show all possible outcomes. So I'm going to draw what is called the L in this case, so it'll be an L. And we're taking 4-sided dice. Usually that's between 1 and 4, so I'm going to do 1, 2, 3, and 4 here, and I'm going to do 1, 2, 3, and 4 here. And wherever the numbers intersect, add the numbers. So for instance, 1 plus 1 is 2. 2 plus 1 is 3, 3 plus 1 is 4, and 4 plus 1 is 5. Go to the next row. 1 plus 2 is 3, 2 plus 2 is 4, 3 plus 2 is 5, 4 plus 2 is 6. So let me write all of these out. So notice there is a total of 16. 4 times 4. So I would call these 16 sample points. Now, the sample space, on the other hand, remember, we're only counting each individual unique outcome once. So start with 2. I could get a sum of 3, 4, 5, 6, 7, or 8. That's my sample space. I know 3 is repeated multiple times, so is 4, 5, 6, 7, and 8, but I'm only writing each individual unique sum once. Okay, so suppose one outcome is chosen at random. Calculate the following probabilities. The probability that the sum is 5. Well, we've got 1, 2, 3, 4 different ways to get a sum of 5 out of 16 possible sample points. That simplifies to 1/4. Part D, the sum is at least 6. So what does that mean? That could be 6 or 7 or 8. That's what that means. So there's 3 6s, 2 7s, 1 8. So that's going to be 6 out of 16. Reduce it into the lowest terms. That's 3 8s. What's the probability the sum is not 3? Remember, I'm going to write it as 1 minus the probability the sum is 3. So that's 1 minus. Well, how many sums of 3? That's 1, 2 out of 16. That's 16 over 16 minus 2 over 16. 14 over 16. That simplifies to 7 8. All right. So at least one die lands on a 1. So that would be this particular column or this particular row, where at least one of the die lands on a 1. Notice it's not saying sum, just landing on it. Let's count. 1, 2, 3, 4, can't count it again, 5, 6, and 7. So here that's going to be 7 out of 16. So keep in mind, the more times you do an experiment, the closer your answer will be to the classical or theoretical probability. Okay, let's take a look at the next example. So here's a standard deck of playing cards without jokers. Now, there's 4 suits. These are called clubs, 13 of them. This is hearts, 13. This shape is spades. That's 13 of them. And, of course, diamonds, which there are 13. Add them up, there's 52 cards total. This would be a good idea to know for the rest of this course. Okay, so suppose one card is chosen from a standard deck of playing cards. You calculate the following probabilities. So what's the probability that you'll select a 6 of clubs? Well, there is 1 6 of clubs out of 52. What's the probability of a red 2? Now that's the same thing as what? A 2 of hearts or 2 of diamonds. So again, that'll be 1 out of 52 plus 1 out of 52. That is 2 out of 52, which is 1 out of 26. What's the probability that you'll select a heart? Well, there are 13 hearts out of 52. Divide top and bottom by 13. That's 1/4. Okay, probability of a 4, 6, or 7. Remember, with the word or, that means to add. That's a probability of 4 plus a probability of 6 plus a probability of a 7. There's 4 4s out of 52, 4 6s, and 4 7s. Add up, that's 12 out of 52. Divide top and bottom by 4, that's 3 out of 13. Okay, probability of not an ace. Remember, I'm going to write it as 1 minus the probability of selecting an ace. So that's 1. How many aces? There are 4 aces out of 52. 52 over 52 minus 4 out of 52. 48 out of 52. Divide the top and the bottom by 4. That's 12 out of 13. Okay, so that's a classical or theoretical probability. The last type of probability is what is called subjective probability. This is an outcome of a probability obtained on the basis of personal judgment. And examples. The chance of the Chicago Cubs winning the World Series is 20%. Maybe this person has seen the Cubs bat, how they pitch, what the rest of the league looks like. It says they have about a 20% chance. The chances that Joe Biden will win the election, or maybe re-win the election, is 35%. Here you can't repeat the experiment, but it does satisfy the criterion for probability.